Hello mathematicians, puzzlers, and other curious people. In this video, we are looking at 4 options of ways to grid out a quadrilateral to figure out its area, and we are figuring out which of those ways will be helpful. Let's get started. So here's our 4 options, and I'd like to look at them a bit more closely. So here's option A, and I do think this is a good option we could use to figure out the area of this quadrilateral. So I see that we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grid squares that we could count easily without having to match anything up. And then I see we have this little piece right here that looks the same size as this right here. And this piece here looks the same as this right here. So I'm going to say let's mentally flip those around. It's almost as if we're decomposing and then recomposing them. And then we would have an 11th and a 12th area unit. So we could say from this that we believe this shape is 12 units squared in area. Now let's look at option B. Now, this one is split down a bit, so we could start out the same way we did before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we could notice that, so through here, we're looking at the squares that we had to sort of decompose and recompose to make, but we're looking at them in a different way. So they're split down into half, like into half linearly, which means 4 in all to make 1 square unit in area. So I would find an 11th area unit here, and then these would need some matching up. But it seems to me that that looks like it would match up there. And this looks like it would match up here. And this looks like it would match up there. So if we decompose and recompose those, we would get a 12th area unit there by making 4 of the quarter area unit grid squares, you know, the split down ones. So again, we find that that's 12 units squared. I like this way because it helps me out with the precision compared to option A. We just had to keep track of the fact that there were a couple of different sizes of squares. Now here's option C, and you know, they say always guess C, but in this case, I don't think that's true. I see we've got 9 grid squares clearly made here, and we've got another 3 here, but there are overlapping spaces and there are left out spaces. Now, from what I already know from before, I think that the left out spaces and the overlapping space here are the same in area, but I don't see a good way to decompose this to something that could cover these to tell. So I don't think C is helpful. Now, you might have an idea of how to use C, and if you can fully work that out, maybe in a GeoGebra build, I would definitely be interested to see it, but I don't think for our purposes C is a good method. Okay, now let's look at D. D is in some ways a lot like B, it's just more split down. We still have to keep track of the fact that each 4 little grid squares here are 1 unit of area, but we have a choice of which 4 we use as we're counting it up. So we can say, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I would do the same decomposition and recomposition that I did for option B to make the 12th area unit. So either way, we still get 12 square units of area. So out of these 4 options here, C is the only one that I would definitely not choose to use based on the ideas I've had so far. As for which one is the most helpful, that's your judgment call. I personally liked B for sort of a balancing of efficient counting and precision, but again, it's your judgment call. You could have a different preference from what I have. Calculator!